Here we go. Question number 4 in our first derivative rule. This is the exact same function that we started with in example number 1, with the exception now that we actually have a domain to deal with. So we're going to deal with the domain from -3.5 to 1. So the original steps are the same. We found our critical numbers. Again, there's no dividing by 0 in the function, so our critical numbers are only where the slope equals 0. Our domain, however, is no longer from -infinity to -3. Now it's square bracket because it stops at -3.5, and square bracket because it stops at 1. But the increase decrease idea, the slope, it's all the same. So we still know that we're going from an increasing function to a decreasing function. So we're at the height of the curve. We're going from a decreasing function to an increasing function. So we're at the bottom of the curve. So those things are the same as number 1. The layer we're going to add is that our critical numbers are about where the slope equals 0 and where the slope is undefined. Now, we haven't really touched on this yet, but if you have endpoints, you don't have a single defined tangent slope at an endpoint. You can have an unlimited number of tangent points through an endpoint. That's why at endpoints you have an undefined tangent slope. Whereas when your slope is 0, that's a defined value. So we want to know what are the function values at -3, -1, -3.5, and +1. We want to find all those values, all those y values for all these x values. So again, when you want to find points on the function, you have to make sure you deal with the original function, f of x function. So when we find our points, -3, 2, -3, 2, -1, -2, -3.5, and 1.125, -3.5, 1.125, and 1 with 18. We can now talk about where do you have locals and where do you have absolutes. So the maximum value you found from your table was a maximum at -3, and the local maximum value is a height of 2. The absolute maximum value is here, though, when the function hits a maximum height of 18. Again, when we're talking about the values, we're talking about the y value. So 2 is the y value, a local maximum of 2. 18 is the y value, an absolute maximum of 18. And down here at this point, this is our absolute minimum of -2. The graph doesn't go below that. So again, the table still works. We've got an increased region to a decreased region, so it tells us it's a maximum. We've got a decreased region to an increased region, so we know it's a minimum. Then we deal with the outsiders, with the endpoints, and we find we have an absolute maximum at 18, and this would be a local minimum of 1.125. All right, that's it for the first derivative lesson. Hope you understood that, and I hope we can solve some problems now.